This article is going to give us a brief explanation of why we don't see colors like red and yellow down deep in the ocean. It starts talking about this image. It says, visible colors of light penetrate differently into the ocean depths, as seen in this image depicting light penetration in Lake Superior. Longer wavelengths, such as red, are absorbed at a shallower depth than shorter wavelengths, such as blue, which penetrates or reaches a deeper depth. Visible red light has slightly more energy than invisible infrared radiation and is more readily absorbed by water than other visible wavelengths. This is why red fish appear nearly black at 20 meters. Light with longer wavelengths is absorbed more quickly than with shorter wavelengths. Because of this, the high energy light with short wavelengths, such as blue, is able to penetrate more deeply. At 40 meters, saltwater has absorbed nearly all the red visible light, yet blue light is still able to penetrate or reach beyond these depths. At this depth, a scuba diver without a flashlight sees all underwater features in only shades of blue, as shown in figure 9.8a. To see a full spectrum of colors, a diver must shine a white light directly on an object. So this has white light shining on it. That gives us a little bit of background into what we saw with the fishing lures and what you're going to explain in your model. Here's another article that kind of briefly explains the same thing. It says, the light spectrum is what we call all of the colors we can see. The colors that make up white light are red, orange, yellow, green, blue, indigo, and violet. When all of these colors mix, it makes white light. Water acts as a filter. One by one, the colors go away as you go deeper underwater. The water absorbs or soaks up the light waves. This happens slowly. For example, most of the red is gone from sunlight after 10 feet. Some of the orange is also gone. At 25 feet, most of the orange is gone. At 35 feet, most of the yellow is gone. This continues through the spectrum until all that is left is violet light. Even violet light fades out after hundreds of feet. This picture shows us where it says, where do the colors go? And then if this at the top represents all of the colors in white light, this is out in daylight air, it shows what colors you lose as you get deeper and deeper and deeper underwater. Finally, there's a little explanation about fluorescent colors, and those are the colors. If you look at the pictures of the lures that we glued into our notebooks underwater, there are a few colors that don't disappear, even though they're red and pink and yellow, when you get deep down into the water. And if you click on this link, you'll hear an audio broadcast of the text that's written below. Make sure that you add some of this information to your model. You'll work with your group to add the things that you think are important. Thanks.